Good evening, students. Now we shall continue with the problems that we have already started. Now the next problem is we are doing the problems based on how to express a matrix has the sum of symmetric and skew symmetric matrices, and in the last example I had taken it for order 2. Now we shall do it for order 3. Now let me consider the matrix 6 minus 2 2 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Now remember, let me consider this to be matrix A. Now as in the previous example, let me take one matrix that we have seen how to write it. Let A be equal to, then what we have done, we have taken A transpose. So similarly I will be taking here A transpose is equals to, what is A transpose now? 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Then I leave it as an exercise for you to find the matrix P and matrix Q. Once you find, and you have to see that P is equals to P complement and Q is equals to minus Q complement. Then P happens to be a symmetric matrix, Q happens to be a skew symmetric matrix. Then add P plus Q, you will be getting A. Now how to find P? P is what that we have seen. P will be 1 by 2 into A plus A transpose. And what is Q here? Q is equals to 1 by 2 into A minus A transpose. That I think so you can do it. If you do not find that this is, you can just message me. I will be doing the problem. I will be showing you the problem there. Now the next concept, these were the examples based on symmetric and skew symmetric matrices. Now the next concept that we are going to study is invertible matrices. Now what are these invertible matrices? Now if you can just see here, if a square matrix of order m and if there exists another square matrix B of the same order m such that, now while you are doing multiplication of matrices, you must have seen that AB was not equal to BA. You have seen that AB was not equal to BA. But if AB is equal to BA and the result is the unit matrix, then B is said to be the inverse of the matrix A, and it is denoted by A raised to minus 1. We denote it by A raised to minus 1, or it is also pronounced as A inverse. In this case, A is said to be an invertible matrix. Now what does this mean? Now remember that you have to take a matrix A. Say it should be a square matrix. It should be a square matrix, remember. Now if it is a square matrix, if it happens to be a square matrix, you have to consider another square matrix of the same order as of A. Say you can say that it is to be B. Then take their product A into B and also consider the product B into A. And if they are equal, that is AB is equal to BA, and you get a unit matrix. Say if A is a square matrix of order 2, and if the final result that you will be getting in both the cases is this is the unit matrix of order 2, or if it is of order 3, then the matrix that you will be getting in terms of I is 1 0 0 0 1 0 0 0 1. Then you say that B, the matrix B happens to be the inverse of the matrix A, and it is denoted by a raised to minus 1. We will be denoting it for inverse. So in brief, you can write it as A into A inverse is equal to A inverse into A is equal to I. Is equal to I. Now, this is one of the important result that you will be getting from the definition of the matrix. Now, you can just see here that here I will repeat this because this is a very important concept. Now take a square matrix, and inverse of a matrix exists if and only if the matrix is a square matrix. Remember this, if and only if the matrix happens to be a square matrix. Now you take a square matrix A, you take another matrix, they should, if there exist another matrix B of the same order as of A, such that A into B is equals to B into A, and the net result, if you get it to be a unit matrix of order 2 or of order 3 or of order 4, but for our syllabus it is for order 2 and order 3, then the matrix B is said to be the inverse of the matrix A. The matrix B is said to be the inverse of the matrix A, and it is denoted by A raised to minus 1. So here A into A inverse is equals to A inverse into A is equal to I. Now this is one of the important result that you get. Now for example, I will take one matrix A. A is equals to 2, 3, 1, 2, and I will consider another matrix, that is 2 minus 3 minus 1, 2. Now what I will do is I will find A into B here. So A into B will be what? 2 into 2 is 4 plus 3, right? 3 into minus 1 is minus, see here, first row, first column. 2 into 2 is 4 plus 3 into minus 1 is minus 3. The next one is 2 into, this is minus 6, right? First row, second column. Then 3 into 2 is 6 plus 6 here. The next one will be 2 into, sorry, 1 into 2 is 2. 1 into 2 is 2. Sorry, second row, yes. 1 into 2 is 2 plus minus 2. Then minus, then first row minus 3 plus 4 plus 4. So what is the result that you will be getting? 4 minus 3 is 1. This is 0, this is 0, so this is 1. So what you get is AB. Similarly, if you find BA matrix, now what we will do is we will be writing BA matrix now. BA matrix is 2 minus 3 minus 1, 2 into 2, 3, 1, 2. Now this will be equal to 2 into 2 is 4 plus minus 3. 2 into 3 is 6 minus 6. Then minus 2 plus 2. Then minus 3 plus 4. So what you get is equal to 1, 0, 0, 1. So from the previous two multiplications, what we have seen, A into B is equals to B into A is equals to I. That is the unit matrix of order 2. So B is said to be the inverse of the matrix A. So that result, B in place of B, if I write A inverse, so A into A inverse is equals to A inverse into A is equals to I. So this is what is the inverse. Then how to find the inverse of the square matrix, that I shall explain you in the next class. Thank you.